All right, so we'll switch over to me here for just a second as we're getting going. In fact, as we're getting going, let's see, we've got a number of people on board here. Let's go ahead, and I've got a few little polls. And so this is kind of a great way to get things started. And I'm going to go ahead and launch this first poll. And this is on, have you had VPN problems before? Because today we're going to be talking about, some ways to go in and troubleshoot VPN problems. And I wouldn't be surprised if we get 100% on this. VPNs are one of those things that make our life easy, but also we run into challenges getting these up and running. We're going to talk about what some of those challenges are and how we can go in and address those challenges. And so, that's pretty good. We've got quite a few people that have answered so far. So I'm just going to go ahead and end the poll, and we're going to share those results. And while we're not at 100%, boy, we're pretty close there. 89% of the people have had VPN problems. So I think that's a pretty good place to start with this. Let's try one more. We'll stop sharing that. We'll grab another one here. And so before we get going, I'm always curious, how many people have an IOTA? And this is kind of what we're going to be, well, not kind of, this is absolutely what we're going to be using today for taking a look at how we're going to address these problems. So if you have one, right on. If you don't have one, well, I'll tell you what, I'm going to tell you right now, I'm pretty excited about what this can do and how we can use it to troubleshoot it. So if it sounds like I'm really pushing it, or I don't want to make it sound like any kind of sales pitch or anything, but I'm a network analyst that gets excited about these types of tools and so on. So I'm going to end that poll, and let me throw those results up. Okay, this is a little the other way. And what's interesting is I did one about 9 hours ago on European time, and 1 a.m. here in Seattle. And we got about the same results. About 3/4 of the people don't have an IOTA, and about 1/4 of the people do. So that's great. So I'm going to go ahead and stop sharing that. And somebody said, out of how many people? Well, 23 people voted. And so we see that out of those 23, we've got about a third, about 1/4 of them have IOTAs. All right, so I'm going to go ahead and shut that down, and we're going to get started. And before we get started, a couple of things. My name's Mike Panaki. I'm here in Seattle, Washington. I've got a company called Network Protocol Specialists, and I work with Profitap to do webinars, troubleshooting, things like that. And so this is a great opportunity for me to go through some of these tools, some of these techniques of how do we troubleshoot things. Also, we have John Modlin on the line, and John is an SE for Profitap, and John is going to be back there available to answer questions. So what you're going to see is that there is a Q&A window within Zoom. I highly encourage you to use it during this webcast. This is a great time to ask questions. And what I'll do is I'll keep an eye on those questions, and if it's something that is good to share with the group, I'll make sure that we mention it in here. Okay. Another question that always comes up is this being recorded? Yes, it is. It is being recorded. So there will be you'll get a link that'll get sent out in a follow-up email to you after the presentation here. All right, and I'm going to switch over to make sure that if I send out a chat, it goes out to everyone. So with that said, let's go ahead and get rolling with our webcast. And again, live webcast, questions highly encouraged. Okay, so a couple things first. Why are we talking about VPNs in here? Well, more than ever, being able to remotely connect into the office place has been critical. People are working from home. People have to work from home. And so they still need to be able to do their work. They need to be able to get to the resources back at the office. So they are trying to remote into that office. Well, one of the big challenges we run into with that is that as a network administrator, we are not always at that office to be able to see what's going on. In fact, in many cases, we're probably working from home as well. So as a result, if we're going to go in and troubleshoot a VPN problem, we need to be able to remotely connect into our office network, and then we need to be able to capture that traffic. We need to be able to analyze that traffic and then get down there and figure out what went wrong and apply a fix to it. So over the years, I've done all kinds of methods. I've set up PCs with Wireshark running out to ring buffers. I'm not going to leave the screen to go grab it, but I've got a little Netgear GS108 or GS105E that I've set up to do spanning so that I could tap in line. What I usually end up with is a lot of packets. And so I need to go through those packets and find out where that problem occurred. And what we find is that when we're going in and troubleshooting these types of problems, not ever has a problem contacted me prior to occurring, or an end user called up and said, I'm going to try VPNing in tomorrow at 10 a.m. and I'm going to have trouble with that. I'm going to need you to capture it. So that way I could get my test equipment in. What we find with almost every one of these situations is that we need to be able to go in, have the equipment placed in line, capturing prior to the problem occurring. And then we need to be able to sort through all of that traffic and figure out exactly where the problem occurred in as little time as possible. Then take those packets and bring those into a tool like Wireshark for analysis. So oftentimes when I'm talking to people about doing packet capture and so on, they want something that's going to capture gigabytes worth of traffic, and then they bring this big gig trace into Wireshark. Or I've shown where we could write scripts to search through a whole bunch of trace files to try and find those specific packets that are part of the problem. So what I'm going to show you today is just kind of a different approach to that. And it's an approach I think that helps us get the problem packets quickly. It helps us get as few packets as necessary to get in and solve the problem. And that's really the key point, is whenever, and especially if you're starting doing packet analysis, one of the big challenges there is getting the right packets and then to start analyzing those. We need to clear out all of those packets that we don't need, that are not part of the problem, to get to those packets that are absolutely part of the problem. So what we're going to be looking at in here is we're going to be taking a look at the IOTA. And this is what I'm using to do my packet capturing. So let me switch over here. And I'm going to switch over to this camera. And here's the IOTA. And I'm going to be very quick with this part about it. But what's kind of neat, I've got it in this little shipping case that it comes in. If I open it up, we've got the IOTA in here. And this is a small capture to disk appliance. So it's got an integrated, this is the 1 gig model right here. It's got a integrated 1 gig fault tolerant tap. So I can tap it in line. I can capture to disk. It's got a 1 terabyte disk in there. Then it's got a management port on the back right there. So I can plug that into my network. I can plug this in line. So in my case, we're going to see that it's plugged in line out on the internet side. In fact, if we switch over here, here's a picture that I took this morning in the back room where I've got my 10 gig IOTA set up. And what's kind of neat, and this is something I really get excited about, it's plugged into this booster. And the booster, outside of the scope of what we're going to be going through in the webcast today, but the booster has 4 inline fault-tolerant taps that aggregate all that traffic into a 10 gig interface that connects to the IOTA. So what I'm doing is I am capturing all the traffic going in and out of my network, both on the inside of my firewall and on the outside of my firewall. So that allows me to come in and I can go in there and make sure that I'm getting the packets that I need to troubleshoot a problem like this. So what we're going to see is we're going to use a web interface to access this. And so we're going to go, I'm going to start sharing the screen here, but we're going to look at how we can use that traffic that we've captured to drill down and find out when are we having problems with this VPN, get that traffic and find out exactly what went wrong. So with that said, let me come over here and I'm going to share my screen so that we can see, you can see what I'm talking about. So we're going to do a share right there. And here's the home page on the IOTA. So what's happening with this? Well, what's happening is when I come over here, I go to my capture control. This has two interfaces on it. Now, it could have the 1 gig interfaces, which support 10100 gig, fault tolerant. We kill power to this thing. It'll keep passing packets through. Or there's a 1 gig / 10 gig model. And that's got a couple of SFP plus cages. And if we want the fault tolerance with that one, we've got to combine it with a tap because it's got the SFP cages. It doesn't fail to wire like the 1 gig does. But in both cases, I can put these in line to do a capture, or I can turn on this span mode right here. And the span mode allows me to capture on both ports A and B and bring that traffic into the IOTA to start writing that to disk. Now, if I come over here, I've had this running for a few weeks. I've captured 152 gigabytes worth of data. Now, I've got a 1 terabyte drive to work with. So what this does is this gives me a lot of depth in my capture. And whether I'm using something like the IOTA or I'm using Wireshark with a ring buffer, the more depth I have in that capture buffer, the longer I can go back in time. And one of the really cool things there is, oftentimes you may find something occurred, and then you want to go back and see, how long has this been going on? How long has somebody been trying to VPN into my network and it isn't working? By having a very deep capture buffer where I'm writing these files to disk, I am able to go back and start looking at multiple instances of the same problem occurring. And if I can find multiple instances, it makes troubleshooting a lot easier. If you just give me one example of where something intermittently failed, that could be a challenge. But if I can go back in time and see what was happening back there, that can save a tremendous amount of time in figuring out what's going on and keep that problem from occurring in the future. So what this is doing is every minute it's writing a file to disk. Then it's going into that file and it's analyzing the flow of traffic in there. It's taking that information and it's putting it into an Elasticsearch database. So we have the raw packets, but also we have all this metadata that we've collected about those raw packets. And so that's where, if I come out here to my home screen right here, I can start taking a look at what my flow of data looks like. So I'm looking at the last 3 hours. I see that I've had 2.4 gig of traffic go across my network in the last, in that time period. I could come in, I could look at, this, I see that there's a pretty constant flow of data going through there. And we could start drilling in and taking a look at what that data is. But if I were to just download this, I would have 2.4 gig of data to start digging through. So if we start digging into the VPN troubleshooting piece of this, I have a couple of different offices that I tie together. And one of the ways I tie that together is I use PPTP as my VPN protocol. Now, I know there's security issues around PPTP. I'm going through the same internet provider. I'm the only person on each end, and doing site-to-site VPNs tends to work pretty well. So what I can do is I know that PPTP uses TCP port 1723. So up here at the top of the screen, I've got filters. So what I can do is I can start adding filters to help me get down to that VPN traffic. So I could say L4, and I have source and destination port. I can choose either one. I could say L4 port, I could say 17, and right there it shows me 23. I select that. Now it starts showing me all of my TCP port 1723 traffic. Now, what we could do is we could say, okay, I see that we've got a device down here where we see some 1723, and I'm interested in that device. So I could click on, every time I hover over that, a couple things happen. I see the download PCAP, and I see a little magnifying glass. So I could come in here and click on that magnifying glass, and now it's going to show me that traffic related to that particular device. Now, if that device is actually doing a VPN connection to my network using 1723 and PPTP, we would also expect to see GRE included in that. So what I can do is, you notice that when I clicked on that little magnifying glass, it came up here and it said IP source equals that IP address. So now it's applied an IP address filter. So we've gone from 2.4 gig of data down to 9.1 kilobytes worth of data. That's a big deal. Now what I'm going to do is I'm going to remove this filter right here. And I see that in this case, I don't have any GRE. So it could be that this device, that port happens to be the source port that's being used. It's the ephemeral port that's being used by the device at the other end of the TCP connection. So in this case, what I may want to do is say, okay, well, maybe that person's not doing any VPN traffic. Now, if I wanted to find out what kind of traffic that was, we could come in and there's a number of dashboards in here. So I could say, hey, I want to do some TCP troubleshooting on that. I could see what TCP ports are in use. So now we see that we've got some 1723, but we also have some port 80. We've got some 443. Another kind of fun one in here that I like is hosts. And this shows me where the traffic's coming from. So in this case, it shows my client location. I could zoom in and it shows that my client location's coming from China somewhere. Well, I can guarantee you I don't have anyone in my network that should be VPNing in from China. So after we get done with this, I might go in and do a little bit of exploring on that one. That seems kind of interesting. I can come back to my home screen. Now, if I click on the home screen up there, we see it cleared out those filters I had. If I use the go to, that keeps the filters. If I click on the home screen, this button up here, it clears those filters. But here's the other thing I want to show you. Let's say you don't know that 1723 is the port for PPTP, and you want to get to that faster. I'm trying to troubleshoot this VPN problem. This is where I can say L7 protocol. I'm going to say protocol name. Now what it's going to do is it's going to show me all the different protocols that it knows to analyze in this list of protocols. So if I said PPTP, now I could come in there and select that, and now it's going to show me my PPTP traffic. So now if I selected this device right here, and I remove that protocol filter, now there's my GRE. That is a client that has actually established a VPN connection. So let's give an example of what we see when we're trying to go in and troubleshoot a problem. And that is that I had one of the people that connects into my network complain on April 15th, about 6 p.m. They tried to VPN in, they couldn't connect. So what we're going to do is we're going to come out here and I'm going to come up to my custom time range. Actually, I'm going to clear all my filters. I come up here to my time range. So this time range could come from syslog. This time range could come from logs on my router. This time range could come from a report from a user. So I could say, you know what? We're going to set up a custom time range here. I'm going to go back just over a week. I'm going to go to April 15th. And we're going to go to 1800. And we'll look through 1900. Because if you ever looked at, I put together 10 truths about network troubleshooting one time, and one was never believe anything that the users tell you. And that is, it's not their fault. I'm not saying anything bad about the end users. I'm just saying that a lot of times they don't know exactly when something occurred. So as analysts, it's our job to have ways to figure that out very quickly. So now I'm looking at 509 megabytes worth of traffic. I could download that, open it up in Wireshark and start analyzing it. But that's going to take a long time. So now what I want to do is I want to come up here and I'm going to slap a filter on there. I know that this person was trying to PPTP in, so I'm going to say, actually, I'm going to show you kind of a neat one in here. This is more of a little advanced thing, but I'm going to say L7 underscore See if, oh, I did get it right. Just wanted to make sure. I was pretty sure it was proto. Wasn't sure if it was protocol, but here's the cool thing. I can create the filter here, or I can type it in right there. And you know what I like about typing it in there? I can copy and paste that into a text document. I've got a whole list of different filters that I can throw in here and apply. So now, oh, we've reduced that filter. I've reduced 500 meg of data down to 76K. Now, this starts showing me the devices that were having problems. So what I could do is I could say, let's take a look at .37 right here. And if I go in and I remove, and I'm going to say, watch this. Oh, this is so fun. I'm going to say, or protocol colon 47. Now, what does that mean? GRE that we use to transfer the data uses protocol 47. So now we've come in and we've set a filter, and I can say, well, we saw GRE there. That means that that connection was established. That connection's working. All right. So I'm going to remove the IP address filter, and I'm going to come in and I'm going to say, well, what about 35? Well, 35 has GRE, so it looks like their connection's working. So I'm going to remove that. Let's say, how about 34? Oh, 34 has TCP, so it has the packets that we would see that we would use to establish the PPTP connection, but we don't see any GRE to go along with that. So what I'm going to do is I'm going to come in here and I'm going to grab, well, look, we're only looking at 60K of data right now. So that's pretty good out of all of those gigabytes worth of data. So now at this point, I'm going to go ahead and click on that IP address right there. So now it is going to download that capture file to my machine. Now, let me rewind just a bit before we look at the capture. This is something I wanted to show you, kind of forgot at the beginning there. If I come out to network configuration, we'll say discard right here. So I'm going to come out to network configuration. And in this case, I could set a static IP address on the IOTA. I can have it grab a DHCP address. But here's one of the challenges we can run into, and that is I'm trying to troubleshoot this VPN issue out there at a remote location. And it could be VPNs aren't working. So now I have an IOTA sitting at a remote location that I can't get to. Well, one of the really cool little features that's in the IOTA is the ability to connect to zero tier. Now, zero tier is a software-defined network. What I can do is I can put a network ID in here. Zero tier will go out, or the IOTA will go out and talk to zero tier and establish a tunnel out to zero tier. And then I can connect into the IOTA through zero tier through my computer. So that means that I can send the IOTA out to a location where I don't have any VPN access. There's no holes punched through the firewall, but I can still get into this web page on the IOTA and start troubleshooting things to see what's going on. So I like that feature in that I can put that in there. So let's come in and let's take a look at this trace file right here. And I'll tell you what, somebody asked a question about who, what, why, what is zero tier. I'm going to let John tackle that one. John's actually been working with zero tier quite a bit. And he can answer that. And I'll tell you what, when we're getting close to the end here, I'll go back and I'll read his answer for you too. But in this case, here is my trace. Here is my packet trace right here of the trace that I captured. And one of the questions is, could I bring the trace back through zero tier? Yes. Yes, I can, because I'm connected to the web interface. So if you're a consultant, this means you could take and set zero tier up on your IOTA, send that out there, and then we could get in there, look at the traffic, bring it back to our machine, and do the analysis. And here's the other part of that. If that's out at a remote site, bandwidth could be an issue. And I don't want to bring back 2.4 gig. I'd have to drag that across the internet. I don't want to bring back 500 meg. I want to bring back 60K. In fact, if we come in here and we look at our statistics and we look at our capture file properties in here, we could see, well, in this case, I brought back 830 kilobytes worth of data. Not too bad. So now I could start going through my packets and I could see right here, protocol reject. Those are the types of words that I don't want to hear when I'm going in to troubleshoot a problem or see. So we see that we saw that protocol reject, termination request, ACK, request ACK, boom, thins, connection comes down. So we see that that's repeated again. We see a protocol reject again. So at this point, what I would want to do is come in and take a look at the configuration on the endpoint and take a look at the configuration on my office. Obviously, based on the other connections, people are getting in and connecting in. But it's when we can get down to these packets this quickly that we're going to be able to start troubleshooting problems. If we can't get the right packets, literally, you can spend days digging through Wireshark traces, trying to find what's going on. So what we needed to do is we needed to find out who was doing VPNs, and then take a look at who wasn't doing GRE in this case. Now, let me just come over because I got to show you this. This is something really slick here. And that is within the IOTA, we have a whole series of dashboards that come with it. Well, John, the SE that's on here, John came up with a VPN dashboard that he sent me yesterday. So he said, hey, Mike, this is a dashboard I put together, and let's open this up. Let's take a look at the last 24 hours. 23 gig of traffic. Now, what John did was he put together a dashboard, and what we're going to do is in the follow-up email that's going to come out, we'll give you a link where you could go out and download this dashboard. After you download the JSON for that dashboard, you could come in to manage, and you could say import, and then you could import that dashboard into your IOTA. Once you do that, what happens is when I come out here, I go to manage and I go to the VPN analysis dashboard, it starts showing me who's doing VPN traffic. So we're going to go back, we'll say the last, 12 hours. So now I see we've got a fair amount of traffic right in here, tells me what protocols are running that. I could see, who my endpoints are. And what I'm interested in mostly is where I see a fair amount of traffic in there. These other ones, these could be attempts at trying to connect to my network using VPN. But now what I've done is I've set it up. The original one had server location. I'm more interested in where the clients are coming from. So if I come in here and I start drilling in, I'm up here in Seattle. So now I could start drilling in and seeing where are my clients coming in from. And I could highlight that and it says, oh, that person's coming in from Comcast Communications. So not only can we go in and we can start taking a look at what the traffic is, we could start taking a look at what type of traffic we see going across there. So to be able to troubleshoot VPN issues, and the IOTA makes it easier for us, obviously, but to be able to troubleshoot these issues, we need to be in the right place. We need to be in the path of the packets. We need to be able to access those packets, even if we can't access our network via VPN. And ideally, we want to be able to do that remotely. We want to be able to come in and troubleshoot that without having to go to that site, particularly now. If I can stay home and I can troubleshoot it, or I can take and throw something in a box and ship it out there, then that is the way to go. So could we do this using a PC and a ring buffer and a $45 switch setup to get in line and capture that? Yeah. Is it going to take us a lot more time to dig through all those packets and find these problem packets? Absolutely. Is it going to be difficult to do remotely? Could be. So what we find is that we need to be able to get the packets. We need to be able to filter on the packets quickly, drill down on that, and have a way to pull those back to our machine so that we can start doing our analysis. So I'm just going to turn off the share. Just as far as, let me take a look at the questions right here. So zero tier, so John said, yeah, zero tier is a cloud-based SD-WAN solution. You can set up your own SD-WAN environment and manage up to 100 devices for free. So the client for zero tier is built into the IOTA. So this is something that you could do if you set up a capture device or something, or if you had numerous IOTAs out there, you could manage all of those IOTAs through zero tier. It doesn't matter what IP address they get out at the remote end. Okay. And then, yes, on the, can we bring the trace file back through zero tier? Absolutely. So everything we can do, we can create dashboards, we can pull trace files out, we can start creating filters up here. And also, one thing that is up there that I really didn't touch on too much, and that's the Berkeley packet filter. If I do want to extract packets from the data that I'm seeing up here, I can create very, we'll call them comprehensive, I hate to use the word complex, comprehensive filters to filter out exactly the packets we want. So to summarize, it's all about getting the right packets in the right place. And once we have those, then we can start going in and taking a look at what failed. So I hope that this has been useful as far as, oh, we got a couple more questions. All right. I want to thank everyone for joining on. I hope that you found the information useful, informative, maybe a little bit fun. I love looking at packets, so this kind of stuff, I always enjoy getting in there and taking a look at what traffic's going across the network. And just as one last note, building dashboards like that, we can build dashboards to give us a good idea of what's happening on our network. So more than anything, I want you to be curious. I want you to be curious about what's going on. I want you to go out there and capture things that work. So whether you're using a tool like the IOTA, you're using Wireshark on your PC, capture things that work so you can compare them with things that aren't working. That is the easiest way to start getting to the root of what's going on. So be safe, be curious, capture those packets, take a look at what's going on out there, and join us for some more of these webinars. We'll be doing more in the future. Thank you very much. I'm Mike Panaki. We'll see you in the next one.